Good morning and good afternoon and possibly good evening, and welcome back to the second day of the Dynamic Spectrum Alliance Global Summit. Hope not all of you stayed up too late last night watching election results. And we're on to the agenda for day two. But first, on behalf of the Dynamic Spectrum Alliance, I'd like to thank the sponsors of this event, and that includes the Access Partnership, Amazon, Aruba, Cubic, Facebook, Federated Wireless, Google, the Internet Society, Loon, Microsoft, and Policy Impact Partners. Now, for the, can I have the next two slides, please? To kick us off today, we'll be hearing from Sébastien Soriano, the president of the French regulatory agency, and will be followed by Gilles Brégant, the head of the National Frequency Agency. After that, we'll hear from Dave Wright, president of the CBRS Alliance, on how CBRS came to be in the USA. As Claude Aitken pointed out yesterday, this is a milestone in spectrum regulation in the US in terms of introducing use it or share it provisions. That will be followed up by a panel session looking at mid-band more generally around the world, and that is a session that will be chaired by Michael Calabrese of the New America Foundation. And then finally, on a more philosophical note, we'll hear from Dan Rubinovitz, Vice President at Facebook, on how spectrum policy thinking is changing. And now, at the same time, next slide, please, we also have pre-recorded sessions, which you can access on the interface there. One looking at the importance of connectivity for community centers in development, which will have Don Means of the Gigabit Libraries Alliance, Alessandro Lustrati of the Foreign and Commonwealth and Development Office of the UK, Jane Coffin from Internet Society. There's a session on spectrum sharing in the millimeter waves. That'll be chaired by Monica Paolini of Senza Fili, and a profile of the Microsoft Airband initiatives and accelerating responses to COVID-19, and some individual presentations, one on adding intelligence to dynamic spectrum sharing from the Council for Scientific and Industrial Research in South Africa, and on academic regulator collaboration in Kenya in the development of the TV white space regulation there, and that'll be from Strathmore University in Kenya. The next slide. And just a reminder that you can access various elements of this event through the different icons on the side. So the main stage is through the stage icon. Down at the bottom, you'll see the Expo icon, and that will give you both access to the pre-recorded sessions I just mentioned, but also to sponsor platforms where you can speak to individual sponsors. During the breaks, we'll have networking opportunities, and you can access that by clicking on the networking icon, and that will pair you up with another participant in this event. And I just want to emphasize that it really gets better the more people participate and the more exchanges there are. Then on the right-hand side, you can see the chat icon. If you have questions or comments for speakers throughout the session today, please feel free to post them there, and we will channel them to the speakers. Next slide, please. If you're following this on social media or posting on social media, please use hashtag DSA Global Summit. And with that, we begin with our keynote speech from Sébastien Soriano, the president of ARCEP. I think we all wish we were in Paris today. I understand the weather is wonderful there at the moment, but we have you virtually, and it's a pleasure to welcome you. Over to you.
Oops, with the microphone is better. Sorry. Thanks a lot for inviting me for this session. Of course, as you mentioned, we are sorry that we were unable to welcome you to France this year. Maybe next year or another time. You already had the intervention of Gilles Brégant from ANFR yesterday, and you will be speaking also after me. Just to mention that in contrast with ANFR, ARCEP is not a state agency in the strict sense of the word, but an independent authority. Our national governance on spectrum is quite unique, to say least, but has many advantages. Today's DSA conference comes at a crucial moment. The tech clash, make it short. For decades, new technologies have been welcomed by the people as, let's say, good by default. But this is completely over now, if you allow me a personal thought. Since several years, technologies are also showing the dark face, let's say, surveillance capitalism, digital addiction, political polarization, and so on. What we are experiencing in France regarding 5G this year in 2020 is a living example of this phenomenon. And I would like to start with this example because I think this is something important to share within the spectrum community. For the first time in France, people are really challenging technology in itself, 5G. They are asking questions such as, what concrete uses in my daily life does 5G respond to? What is the society model behind the Internet of Things or behind the gigabit society? Is 5G the real priority when the planet is burning, when the economy is collapsing because of the COVID-19? And these kind of questions, they don't come only from amateurs of conspiracy theories, but from, let's say, the man in the street, from intellectuals also, and even from mayors of large cities like Lyon or Lille. The lesson for me is the following. We, public authorities, but also private companies, we cannot roll out technologies without the people anymore. It is not only a question of finding a better balance between the state and the private companies. It is nor a question of only associating more or better the people to the public decision. To me, the right answer is to enable the people to act inside the technology, which for a regulator means empower consumers, local authorities, entrepreneurs, associations, communities of developers and makers. It means being part of the definition and the rolling out of technologies for these people. To put it in a nutshell, it means we have to regulate for the commons. Let me explain what spectrum has to do with it. From 2015, our priority in ARCEP was to start from what the French population needed the most. At that time, their need was clearly identified. They needed 4G coverage and quality of service. In 2015, just to give you an idea, we have in Europe ranking of countries in terms of 4G coverage, and over 28, we were 28 in Europe at this time, over 28 countries, the ranking of France was 26. So it was very bad. This demand from the people was something very, very important and urgent. That's why we have decided to conclude a very specific agreement between ARCEP, the telecom regulator, the government, and the telecom companies. This agreement is called in France Mobile New Deal, but sometimes you may have heard of it at international level as Spectrum for Investment Deal. It's a very innovative process that has globally been applied, which the idea is that in anticipation of the renewal of certain frequencies, national operators have committed to deploy their 4G network in rural areas at a very ambitious level, more than 3 billion euros of investment. But what I would like specifically to underline here is the specific role granted to the mayors of local authorities in this program. The places where antennas coming from this program are installed are not decided in Paris, nor in the office of the operator, nor in the office of any minister or agency like ARCEP. But the decision comes from the local populations themselves through the voice of their mayor. Of course, there is a limited number of new sites, between 600 to 800 sites every year per operator, the new site installed, and a global arbitrage is needed. But this arbitrage is coming from the real needs expressed by the people. In other words, spectrum for the people and by the people. And we can go further by promoting spectrum sharing, which is, of course, something you very much care about here. In France, we had in 2014 a very interesting report from Joël Toledano about dynamic spectrum management. And we are now in the implementation of this report. First, what this report led ARCEP to do is in 2016 to open a regulatory sandbox. The idea of this regulatory sandbox is that you can use frequencies without complying to the whole regulatory regime. A little bit like sandbox that exists, for instance, in UK in the banking sector. Thanks to this sandbox, we have initiated very interesting consortia that are testing really fascinating use cases in the Internet of Things on the 26 gigahertz band of frequency today. But we would like now to accomplish a further step. We published a note dedicated to spectrum sharing issues last year, together with our scientific board. Already, ARCEP has authorized an interesting experiment on TV white space during the last years, notably with Microsoft in the region of Gers in France. But the next big question will be raised by the allocation of the 26 gigahertz band. We expect at least part of this band to be shared between various users, especially businesses. This will be a fascinating challenge for ARCEP. It will be a little bit of our first time in that kind of allocation, and we hope to develop partnerships with other European countries in that context. This is, in my mind, a unique opportunity to enlarge the ecosystem of 5G players. As the American lawyer Yorkshire Banker, the author of The Wealth of Networks, has long stated, radio spectrum is a particularly favorable medium for the establishment of commons. These are the famously known spectrum commons. From the point of view of the state, this is not without conducting to some big changes. This means moving forward with a little more flexibility and also accepting the unknown part of innovation. The possibility of instituting commons can be facilitated by public power and or the market sphere, as Dankler says. Network neutrality is an illustration of this phenomena in another field, as spectrum policies. With regard to telecom, still not enforced, as you know, in the United States. Net neutrality guarantees in Europe the open architecture of the Internet, which allows expression and innovations to take place without state or market control. Thus, the informational common goods represented by the emblematic Wikipedia are made possible by the network infrastructure, which are the result of mostly private and sometimes public investment. If we are to respond to the demand of our fellow citizens regain control of our technology. Now, I'm not talking anymore about telecom only. We need to be ambitious. What is at stake is not only to recognize, but also to empower the commons. Thank you very much for your attention.
Thank you very much, Sébastien. That spoke to my heart in many ways. I think that we understand that technology is, can be an amplifier of inequality, and its implementation has to be more carefully thought out. I have one quick comment before we go, or question before we go to Gilles. I'm a fan of the Mobile New Deal, and there was one aspect of it that you didn't mention, and that was the issue of transparency, and that the Mobile New Deal is founded on an open data platform, and that having more transparency, for me, I think, is a key to more engagement from civil society and a more citizen-driven approach to regulation. Perhaps you could comment just briefly on that.
Yes, all the data from the rolling out of the network within the frame of this Mobile New Deal is on open data. So we have a specific dashboard dedicated to this program, and every month we publish the different steps of the program, and so you can check whether operators are respecting the obligations, because as it is a deal, of course, on the one hand, the state have made an effort on the spectrum, and so on the other hand, we have to make sure that the commitments are really respected. So we have put full transparency on that. Yes, of course, it's very important. You're right.
Merci, Sébastien. And now we will turn to Gilles Brégant, Director General of the National Frequency Agency. Welcome.
Thank you very much, Steve. Good afternoon, good morning, good evening to everybody. So it's nice to be with you today again for a keynote address. And for a keynote address, as a spectrum manager, I will simply raise a number of issues. I don't know if I could get maybe, okay, excellent, thanks. I will simply raise 4 issues just to trigger the discussion about spectrum sharing. So the first issue is simplicity versus complexity. So I'll start by a French quote which reads "Ce qui est simple est toujours faux, ce qui ne l'est pas est inutilisable" by Paul Valéry. That means what looks simple is inaccurate, and what is not simple is useless. And that applies very well to spectrum sharing, in my view, as a spectrum manager. Because if spectrum sharing schemes are complex, if they read complex, they won't be used. That's my experience. So maybe three examples. The first example is the harmonization process that we're using very constantly in Europe. Why do we use harmonization? Because harmonization is a hidden complexity. You work hard during years to actually harmonize a spectrum band and the user manual. And then at the end of the day, it comes like an IKEA chef. Everything is ready. You simply have to take a screwdriver and you can use it. And it's trouble-free, it's simple, it's very cost-effective. The manufacturers love it because it's ready-made. They've been involved in the process of producing the harmonization. It was hard work for years, but at the end of the day, it's very simple and it's usually successful. That's very important in Europe because, as I said yesterday, we have 27 countries here that have to implement that. So that creates complexity. So you have to be simple at the beginning, just to be able to accommodate the complexity downhill when you actually realize the system. So harmonization is a way to achieve something that looks simple, and that's usually very successful. But of course, it's not extremely flexible. It's not loose binding. It's not as the internet guys say, rough consensus and running code. You have to actually to write down the code first, and then it's easy to implement. So harmonization is not necessarily what we want to use for spectrum sharing, but it's an example showing that what looks simple sometimes is complex to produce. The other example I'd like to develop is a 2.3 gigahertz band in France. This band is used in France for governmental usage, but at the same time, it's been harmonized for mobile, for IMT. So we had a big program to actually implement it on the basis of a license shared access, because the governmental forces don't use it every time. So in places, in times, you can actually use it as a network operator to do simply IMT. So we made a process here to actually put all the stakeholders together and try to find an efficient solution between governmental persons and the mobile operators. But at the end of the day, it wasn't a success because the operators did reject the offer as too complex. And a few months later, as we had a number of security problems due to various attacks in France, there was a stronger use of this band, and at the end of the day, the governmental users sort of went out of the scheme because they required more spectrum. So when you don't have the simplicity, sometimes you miss the opportunities, which was the case of the 2.3 gigahertz. Maybe it'll come back when we stop epidemics and other troubles. But as a matter of fact, it's very important to have here something that's ready-made at the right time. The third example about this issue is the C-band for 5G. In Europe, we managed to clear the C-band rather early and harmonize it between 3.4 and 3.8 gigahertz. And as a matter of fact, it looks like it's going to be a success for 5G deployment because it's been allocated to mobile operators in various countries, and now it's being deployed for 5G services. In the States, we had CBRS that will be developed just the next presentation. CBRS is rather complex, but at the end of the day, what seems to happen now with FCC is that the federal state is moving towards something that looks like harmonization in 3.7, 4 gigahertz for the next step of C-band 5G. So here, the main message is that when you want to use a shared scheme for spectrum usage, you have to make it look simple. Otherwise, nobody will actually swallow the bait and get into the scheme. And that's not easy. As a spectrum manager, it's very difficult to make this look simple. Maybe the next issue, the next slide, please. So the other idea is the confidence-free life cycle. So that reads apparently "develial no prevelial." It's a Russian proverb that means trust but check. It's been used by Lenin, by Stalin, but also by Ronald Reagan. And as a matter of fact, this proverb is here to say that we need to have good confidence throughout the life cycle of spectrum. My agency actually does spectrum management from the beginning, which is spectrum allocation, band allocation. And we have a view on all the bands because we can actually act in the military bands as well as in the civilian bands. All the spectrum, actually, we have to manage all the spectrum, but also down the life cycle because we're supposed to control the use of spectrum. And we're supposed to do spectrum police, as a matter of fact. So we see what happens when there is not enough, I would say, theory at the beginning. For instance, the example I used yesterday in my quick speech was the Wi-Fi at 5 gigahertz with weather radars. This system has been used for about 10 years, and it was seen as a brilliant theoretical achievement because weather radars are rather rare on the territory, and they are easy to spot because they have a ping and that you can spot when you actually listen to pings. And so it's easy for you to actually implement a Wi-Fi system in a white space where there's no weather radar, and that's win-win, in fact, because the spectrum is not used here and the weather radar is somewhere else. As a matter of fact, it's a huge failure because in Europe now we have a number of weather radars that are losing their capacity of predicting time because some azimuths are simply blurred by the Wi-Fi systems. In France, you have lots of small villages that are implementing, for instance, closed-circuit video cameras just to check what happens for the local police and so on. And in fact, it can jam a radar as far as 100 kilometers from here. So for my agency, it takes thousands of euros to actually send, I would say, spectrum policemen to stop the Wi-Fi system. And the Wi-Fi system is sometimes, let's say, less than 100 euros. It's a very basic system. So it's not efficient at all. The spectrum sharing scheme is not efficient. And at the end of the day, we probably will have one day to move the weather radars in another band to make them efficient, because we've got global warming and we've got hurricanes, even in France sometimes, and we have to know that before. So as a matter of fact, this scheme is not efficient because there's been much effort put on the theoretical, I would say, beginning of the life cycle, but nothing done down the hill, down the life cycle, and now we have to control it through a system for market control. In fact, we have to do in Europe market control based on testing on systems which are freely sold in Europe, because actually you can access the European market just by providing a few documents saying that you comply with the requirements for Europe, but you have no check prior to access the European market. So this scheme is not very efficient because it's been too light in terms of organization. You've got too much efforts at the beginning and too small efforts down the streamline, down the life cycle. So the conclusion is that if you have the best engineers elaborating the most efficient sharing scheme, if it's only theoretical, it doesn't provide confidence in the system. So what we have to do is to see the process as a whole from beginning to the end and make sure that we actually build up confidence between the various spectrum users and see it as an asset, a very fragile asset, because if you break the confidence, it takes decades to recreate it. So let's build the confidence and let's imagine from the beginning how to check that the confidence is well placed. Maybe the third idea I'd like to develop. Yes, the third idea is that we need to make sure that we don't get mixed up between means and goal. Spectrum sharing has been devised at the beginning to make the best use of white spaces, just to provide connectivity to all. As Sébastien said just before, in fact, we found solutions now, for instance, the French New Deal, to provide more connectivity by, let's say, very conventional methods, which are just relays and licensed operators. We also have other ideas now to bring connectivity to rural areas, for instance, through HAPS, so the high altitude platform systems, or the HIPS, so the HAPS as IMT-based stations. So we have the aerial solutions to provide connectivity above the rural areas. Above the HAPS and HIPS, you've got the satellites. And you got also now in the landscape, far off, the 6G coming, And the 6G says it will provide 5G connectivity, but to all environments. So 6G is going to provide more connectivity. So the connectivity to all, which was a critical issue and still is a critical issue now for all countries, is the goal. That's the goal, and we should keep this goal, because this goal is important for progress, for I would say simply policy making, for using for using connections even in times of epidemics and pandemics. But at the same time, we have several solutions. Spectrum sharing is not the only solution, so we should not get stuck with the means, and always keep an eye on the goal. And this goal should actually be implemented by the available means. And the means today are more and more numerous to achieve that goal. So let's get focused on the goal, not on the means. If you come back to the white space system, the white space system is a nice concept. We've been making in France tests of implementation with ARCEP in rural areas. It works fine. The only issue is that we don't know exactly how to rearrange the frequencies when the frequencies change of use. For instance, in France, we have a system in the C-band for rural areas. We have a radio local loops implemented at the bottom of the 3.4, 3.8 band, so 3.4 roughly. And there we have relays that can provide DSA-like connections without wires, of course, Hertzian DSL connection, if I may say, to rural areas. This system was licensed by ARCEP 2 decades ago. It provided a good service, but now we have to clear this system just to allow 5G to be deployed here. And that's very easy for us, because my agency is also in charge of rearranging spectrum. So what we're doing is that we know who is using that spectrum. We know the local operators using this DSL-like service, and we pay them to go somewhere else. In fact, we actually sort of pack them at the bottom of the band, and everything is very smooth. What would have happened if we had white spaces instead of licensed operators? It's not impossible that clearing the band could have taken us years instead of months. So when we go here about the goals and means, we need also to think on how you can actually change the usage of spectrum when you have persons which are not totally controllable by the national agencies. And all the logics of digital dividend were another way to use the white spaces, because in fact the white spaces now are scarce because we've cleared so much digital dividend before. So we need here to use all the panel of techniques to find future-proof solutions, in fact. So maybe the last idea I'd like to push towards the audience. Maybe the next slide. Okay, the last slide. The last slide is really to find more balanced demands. Spectrum managers usually see, all issues in spectrum usage. For instance, you have an issue which used to be, should I go satellite or should I go terrestrial? I've seen so many consortia asking for a satellite license with a terrestrial part of the license, just to increase the coverage in some tiny parts. At the end of the day, there was no satellite, and it ended up terrestrial. Now things are beginning more balanced in satellite and terrestrial, because in fact you've got an easier access to satellite, low orbit satellites and constellations, and you've got the satellite appears in the equipment now of mobile operators too. So we find a better balance between satellite and terrestrial, and that's a sign of maturity, in fact. If we come to another very, very old issue for spectrum management, licensed versus unlicensed, I don't see yet the same maturity here in the thinking about licensed and unlicensed. Unlicensed is seen as more liberal and more efficient, and Wi-Fi, of course, is the example, the good example of the unlicensed, I would say, approach and unlicensed benefits. But as Sébastien said just before, today we have issues with the French community about all the systems or the relays that are producing waves, producing microwaves and so on. And we feel that it is very important for the citizens to know that there is a control on the systems that actually put waves in the landscape. And the fact that there's a control on these waves is important. So there's not a need to license everybody that actually provides a relay, but there's a need to know where the relays are, what are their power, whether the power is adequate or inadequate, and so on. And so the debate about licensed versus unlicensed needs to get more mature. It needs to get also more mature because we have more spectrum available today. A few years before, there was no point discussing about millimetric waves, for instance. Millimetric waves were research topics or just good for satellites or least links. Now, millimetric waves are used for terrestrial applications, and they are very easy to share, in fact, because they have a very, very close range, so you can share them very easily. But you still have big fights about implementing, for instance, shared systems in the 6 GHz band. But the 6 GHz band is extremely important also for 5G. So we're going to spend a huge energy in trying to know in WRC 23 whether we should use the 6 GHz for Wi-Fi or for INT, and that's going to be extremely painful. Maybe the next WRC is going to last 1 week more. The last one was very hectic. And as a matter of fact, is there a need to have a discussion today about sharing spectrum in parts where spectrum is on a huge demand? I'm not sure. There's a need for a better maturity about the place where unlicensed is adequate. And maybe there's a need to drift the unlicensed demand on bands which are easier to share and already shared for some of them today because they have short range, and also it's a land of plenty. You've got lots of capacities in millimetric waves. So in the battle for Wi-Fi, we should know where to put the battle, because good captains and generals first they select a place when they want to have their battle before fighting, in fact, and that's a good part of the victory. So I'm sure that there are lots of opportunities in higher waves for WiGig, and that's I think a very good target for applying spectrum sharing. So these are just 4 questions that I'm bringing towards the audience to find better solutions to implement spectrum sharing, because spectrum sharing is part of spectrum allocation, and I'm sure it has a bright future, but it should actually select the right battles. Thank you very much for your attention.
Merci, Gilles. Thank you. I learned some new quotations today, which I shall be storing for myself. It reminds me of Einstein's famous quotation of "Everything should be as simple as possible, but not simpler." And it was a great illustration, I think, of just of the complexities faced by the issues around spectrum sharing, but also that spectrum sharing can't be seen in isolation, that it has to be seen in context with other technologies, other models as well. We have one question of clarification, and that's from Detlef Fuhrer from Hewlett-Packard Enterprise. And he was asking about your comment about the interference of weather radars in Wi-Fi. Was that caused by a non-compliant, that is, illegally operated Wi-Fi equipment? Is that what you were referring to?
Yeah, in fact, the equipment is not sold as non-compliant. The equipment is sold as compliant, but on these systems you can actually parameter the equipment because lots of Wi-Fi systems can actually be programmed. And what happens between the hands of the buyer of the system is, after some time they discover that actually if they just put the right parameters, it works much better because actually it uses all the channels. So the problem is that yes, we have systems which are sold as compliant, but which are implemented as non-compliant. So they don't necessarily listen to the pings of the radar. And for our controllers, that's a nightmare because, in fact, you can actually see the radar is jammed in a given direction. So they go to the radar station, they get the azimuth. So they actually get the direction, and then they have a car with a gonio system, but the roads are not straight ahead. We have no helicopter. I'd like to have a helicopter. So the government doesn't want to buy a helicopter for our agency, but with a helicopter it could be better. Just like Apocalypse Now, just go and fetch, search and destroy the equipment. But with the car, it's a bit different. So in fact, you need sometimes 2-3 days to be able to spot the system. And usually it's not a terrible system, but it costs us 3,000 euros just paying the guys and the petrol and so on and the hotels, and after sometimes it starts again because when you stop the ping research system in the Wi-Fi, it works much better. So there's a problem with making the software impossible to fiddle.
Thank you for that clarification. Well, with that, I think we've come to the end of the first session, and thank you, Gilles, and thank you, Sébastien, for your keynote talks. And we will come back in about 20 minutes at 9:40 Eastern Time, or I think that's 2:30 UTC, and where we will hear the history of CBRS spectrum regulation development in the US. And looking forward to that. In the meantime, please join us in the networking area, meet some of your fellow participants, meet some of the speakers, and I look forward to seeing you there. Thank you.